All right, so today, pretty intuitive lesson. Today is a pretty intuitive lesson. We are looking at what constitutes a linear relationship versus a nonlinear relationship. And it is, like I said, I think pretty obvious once we start to talk about it. And so we're going to see data presented to us in a few different ways. I want us to annotate in these boxes together exactly what we're seeing, which tells us whether it's linear or nonlinear. So on the left, those are all linear. On the right, those are all nonlinear. And so when we look at a linear graph, I actually don't want to overcomplicate this. You should see a straight line. If you see a straight line on the graph, that is linear. Easy as that. Okay, well, if linear is a straight line, nonlinear is a curve. The second you see any sort of curve, it might be a parabola like we have here. It might be something that looks different. It might, again, anything that's not a straight line, nonlinear. Instant nonlinear. Now, for their equations, one, these are the actual equations for the lines that you see. And so, things I want us to notice. When we do not see an exponent, what is that power? When we do not see an exponent, what is that power really, Gabby? It's a 1. Anything that's linear always has a power of 1. Now, when I talk about powers and exponents, I'm talking very specifically about x. And so in linear equations, x has a power of 1. So power is equal to 1. On anything that is non-linear, simply put, the power does not equal 1. We will often see the power being like 2 or 3 and like identifying that. Later on in the year, we'll talk about what does it mean for a power to be less than 1. Plays by slightly different rules, but again, even if it's less than 1, it's nonlinear. Now, for a table, we have to do, arguably like the most annotating, but it's the annotations that people were really like trying to make as we've looked at tables all this week. And so what I want to check on a table for linear versus nonlinear is how is y increasing? That's what I want to look at. And so from -8 to -6, I can see we add 2. Okay, next we add 2, add 2, add 2, add 2, and add 2. What do you notice about those numbers? It's constant, right? And like, not a trick question. All of those are the same. That's what you need to see for a linear equation or linear function. It needs to be a constant increase. If it's not, spoiler, it is nonlinear. For example, I guess we're going to change that. This is my bad. I want to change this from increase. I'm going to say change, constant change. Only because we can have a negative change, right? If I were to subtract 2 and have that be constant all the way down, that would still be linear. It just isn't an increase. Over on the right, we have -10, and then we have -6. And so literally within the first two values, I have two different numbers. As soon as I see that, it is out. So this is not constant. Now, this table and a little bit of what we see on the back is truly just going to be like our guide for today when talking about practice or exit ticket or anything else when determining if something is linear or nonlinear. Are there questions right now? All right, once you've got these, flip the notes so that I can see, please. All right, make sure you annotate with me next time. All right, so on the back, before we get into the guided practice, you can see there's actually like a few more examples here. And so these are linear equations with a potential nonlinear counterpart. And so for this first one, right, this first linear, y equals 3x, very straightforward. Underneath, where do you notice this x has moved to? Move to the power. We cannot have x in our exponent. This is something with a very specific name called an exponential. We will not deal with those in here. However, if x is in the power, it is a no-go. All right, second one. Notice the difference, please. In this top linear equation, x is in the what, Amir? For the linear. It is in the numerator. It is in the numerator. Underneath, it is in the what will denominator. And so if we're thinking about things that are linear and things that are not linear, numerator is linear, denominator nonlinear. Denominator also creates an interesting set of curves on the graph. And then lastly, I think this is easy to see, right? We have a power of 1, which is all good, versus a power of 3. Can't have that. So now I want us to get into our guided practice. T question. Yes, so if x is ever in the denominator, it is nonlinear. And so if we look at specifically, right, A on example 1, we want to identify things that are nonlinear. Okay? X is in my denominator. Everybody, is A linear? No. And because it's not, I'm actually going to circle it. Right? I want things that are not linear for this question. On B, is B linear? Yes. Why is B linear? T. Yeah, so we got y equals, we've got 2x plus 3. Specifically, what do you notice is with the x? Or what's not with the x, Will? Power 1. And so when we think of linear versus nonlinear, truly, I need you to zoom instantly into where is x, what's around it. That's linear, it's out. Now, C. C is a trick question. Can I identify whether or not this is linear or nonlinear yet? T. Amir? And so when we distribute, we should get T, everything was spot on except for that one exponent. We should get 6x squared. As soon as we see the squared, is this linear anymore? Nope. And so I'm going to circle it. And then D, is D linear? Yeah. Well, wait a second, though. Why is D linear when A was not? Why is D linear when A was not? Naughty. Absolutely. All about numerator versus denominator. And then E, is that linear? Uh-oh, I've got no and I've got yes. What do we think? Why yes? Amir? Yeah, we have exponents of 1. Now, I'm even going to go so far as to say, actually no, I'll rein that comment back in. X has a power of 1, Y also has a power of 1. This is linear, so we actually don't want this. This just happens to be in standard form. We'll see this in a little bit as we continue to move forward. All right, example 2. We're doing the same thing. This time, we want linear. I'm going to move through this a little bit faster. On A, I have a power of 2. Is that linear? B, power of 1. Is that linear? C, x in the denominator. Is that linear? D, power of 1. Is that linear? E, standard form again. Is that linear? All right. Any big questions right now on notes? Does this feel fairly intuitive? Okay. You got 1 minute. Glue these in.